Hello class, so in this video we're going to be going over another integration technique. This is called integration by parts. Okay, so here is the formula for integration by parts, and right now you might be looking at that going like, wait, what? Like, what is this? Because you see a whole bunch of random symbols. So let's kind of illustrate it first to see what's even going on here and why it works. So let's just take this, and with the thing that I had up there, let's just consider this U, and consider this dv/dx. So make that be some sort of derivative. Then what we end up with is this equals u times v minus the integral of v du. Okay, so how are we going to work with that? Well, if we let u equal x, then that means du equals dx. And then if we let dv/dx, so actually let's make dv equal cosine of x dx. I'll show you that through this. Integrate both of these, then we get v equals, let's see, sine of x. So now we have a u, a v, a dv, and a du. So we can just easily substitute that into here. What is u? That's x. What is v? That's sine of x, minus the integral of v, which is, again, sine of x, and then du, that is dx. Okay, that makes things easy, right? X sine of x minus negative cosine of x plus c equals x sine of x plus cosine of x plus c, and that is the integral. So now I'm going to go back up there, have you copy that down, go back down here, you can take a picture if you need to or whatever, and then we'll move on. So there's that u, there's that dv/dx, or you can just say dv with a dx on the other side. Back down there, I'll show you again, I'll reiterate it, equals this. And when you have limits of integration, I didn't down there, but if you do, you just evaluate the thing like this. Okay, so I'm gonna move back down. So notice we have that same thing, just without the limits of integration. And just reduce things. And what you want to do with the u is choose something that's easy to take the derivative of, or for dv, choose something that is easy to integrate, or easier to integrate compared to the other thing. Or at least we'll make the problem not more difficult if you integrated the other thing. Okay. So the logic of this is essentially we're trying to reverse the product rule in a way. And you essentially want to do this if the integrand itself is a product. Otherwise, it's kind of useless, except there are certain very specific cases where you're going to want to do it even though it's not a product. Because you can also use dx. You can also let dv equal dx. So I'm just going to leave that right there and make dv look better. So you can do that. That works. Because that's essentially dv/dx equals 1. Alright, so let's go on and practice some of this stuff. So speaking about that whole thing up there, let's see, what can we let equal u here? Well, there's only one thing, ln of x. Alright, so that means du equals 1 over x dx. And then we can let dv equal dx, and then v equals x. Okay, let's just try going through with this and see what we get. Okay, so uv, I'm just going to write the v first because x dx is what you want to write. X ln of x rather than not. Okay, from 1 to 2 minus integral from 1 to 2 of v du. So v is x, and du is 1 over x dx. Oh, hey, look, that actually looks pretty nice. So we get, okay, 2 ln of 2 minus 1 times ln of 1 minus the integral of 1 dx from 0 to 2. So that's gone. 2 ln of 2 minus x evaluated from 1 to 2. 2 ln of 2 minus 2 minus 1. Alright, so then that's just 2 ln of 2 minus 1, and that's our integral. So notice that we did have to choose something that maybe didn't look so nice after we did the derivative, but it would have been a lot easier to take the integral of dx rather than ln anyway, and we actually ended up with something really, really nice. Alright, so then let's look at another illustration right here. This thing. Okay, so it's kind of hard to tell which one we want to do, but let's just try things, see what we get, because either way we're going to get a whole bunch of derivatives and integrals that just repeat, because e to the x and sine, they naturally do that, right? So let's just let u equal e to the x, du equals e to the x dx, dv equals sine of x dx, v equals negative cosine of x dx. So either way, a negative is going to get introduced somehow, so it doesn't really matter too much where. Okay, uv, and then that negative I'll just put in front, minus the integral of v du. So that minus is going to turn into a plus because of the cosine. Whoops. Okay, cosine of x times e to the x dx. Alright, so we have negative e to the x times cosine of x plus this thing. So let's try to make that look a little bit better, clean it up a bit. Gonna make some space because we're actually gonna have to integration by parts this thing again. So this time I'm gonna let u equal e to the x again. Du equals, well, e to the x dx yet again. And then dv equals cosine of x dx. Integrate that, we get v equals sine of x dx. Alright, so this is going to be interesting. We get e to the x times sine of x minus the integral of v dx, so v du, so that's going to be, so you're going to have e to the x. I'm just going to write that first, times sine of x dx. Alright, so cleaning that up, I'm just going to clean it up down here and write the integral of e to the x sine of x dx equals negative e to the x cosine of x plus e to the x sine of x minus the integral of e to the x sine of x dx. Okay, so what nice thing happens here actually is, let's look at this. and this. They're the exact same thing. I'm going to add one of them to the other side, so we get 2 times the integral of e to the x times sine of x dx equals, and I'm going to factor out e to the x here, or negative e to the x, why not? Cosine of x minus sine of x. I'm going to add a plus c because indefinite integral. If we just divide 2 from both sides, what we end up with is negative 1/2 e to the x times cosine of x minus sine of x plus c, and that is our integral. So notice that essentially what I did was I did integration by parts twice, got the original thing that we had, and then just added to the other side, divided by 2, then that's what we have as our antiderivative. Alright, so that's the end of this. Hopefully that was helpful, and I'll see you in the next video.